So I'll just go through them again. So object A is used to measure length. Object B is used to measure time.
Time.
Object C is used to hold objects mounted. They want to hold something in the air. Object E is used to measure mass, and object F, I believe, is used to measure temperature. Right? When you get in the notes, you will get these matched up with the actual um, names of them. Right?
Okay.
All right. Can we guess what object F is used for?
Sir, that's heat.
Right. So this is
Sir,
a heat
generate
source.
heat.
Right. So we have gas coming through this section here, and then we have heat or fire. We have fire coming through this section, right? And object G, can you guess what G is used for?
What, sir?
Object G, what is object G used for?
Repeat. Measuring.
Measure
Liquid.
liquid, right?
Liquid.
Liquid. And we use this object to really hold liquid. So we use it as a cup in the science lab. We mostly use it as a cup, right? We don't really use this particular one to measure liquid. We just use this one to hold liquid or to store liquid. All right, use this one to store liquid. And what is this one used for?
Measuring.
We also use to measure, but it's used to measure small distances, right?
Edge.
Right. So say we want to find the diameter
What
of
are you eating?
a marble. So we want to find the diameter of a marble, right? We can't use a meter rule. We would have to use a smaller object, and you'll see the name of this popping up in a few seconds, right, in a few slides. And this one you probably won't be um able to identify this one, right? But this is used to measure current.
Sir,
Hmm?
current, sir.
Yeah, this one is used to measure current, and you can guess what this one is used to measure?
Um, s- um, Radiation.
No, voltage, right? Voltage. So you want to essentially look up here, right? For this, you have MA, which will represent for current, and you have V, of course, for voltage. So you'll see these names popping up now, right? So here are our names, right? So our meter rule is used to measure distance, as we said. Our stopwatch is used to measure time. Our clamp stand is used to hold items mounted. Our top pan balance, right, which was the little balance, the little thing that we had to measure mass. It is used to measure mass. The thermometer is used to measure temperature. The Bunsen burner is used as a heat source, right? The same guy that we saw, right, where it has a little outlet there. We have gas going into the outlet, and then we have fire coming out at the top, right? As we said, we have gas going into here. This is called a Bunsen burner, right? A Bunsen burner. And we have a beaker, right? Beaker would be this guy here. This guy, this is used to store liquids. We don't really use this one to measure the volume of a liquid. We use it to store liquid, right? Because we mainly use it as a cup, right? We have other equipment here to measure liquids, right? And then we have the vernier caliper. Vernier caliper is this guy right here, vernier caliper, and it is used to measure small distances. The vernier caliper is used to measure small distances, right? So, so you want to find the diameter of a marble. We have our marble here, and we want to find the diameter, which would be the distance from here to here, right? We can't use a ruler. We'll have to use a vernier caliper to get an accurate reading of that. We have our ammeter, which is used to measure current, and you want to look out for the MA here, representing the ammeter, right? And then we have our voltmeter, which is used to measure voltage, and of course, you look out for the V here for the voltage. So, are we good so far? You want me to go over any?
No, sir.
Are there any questions? Or thank you, Travis. Anybody else
No,
has any
sir.
questions?
No, sir.
You can send it in the
No.
chat. All right, so we're good. So, if you're going to get a question on this, you'll be required to be able to know that the meter rule measures distance, and you'll be required to know that the stopwatch measures time. And of course, if you see any of these pictures popping up, you should be able to identify that. You should be able to identify a meter rule. You should be able to identify a stopwatch, a clamp stand, and a top and balance. And you should know what these are used for. Very easy, right? Very,
Yes,
very,
sir.
very easy. All right. So I think we can move on if there are no more questions. Am I moving too fast?
No, sir.
All right.
Yes, sir.
No, sir.
So now the next thing on the agenda is to complete lab rules. Right? Lab rules. No. The most important lab rule is to what exactly? What is the most important lab rule?
Follow
Sir, you
instructions.
must,
Follow given
sir, you
instructions.
must, sir, you must not enter the lab without a teacher.
That is a lab rule, but the most important one here.
Sir, you must not use utensils just so.
No, let's look at the
Follow given
slide.
instructions.
Let's look on the slide. The most important lab rule is to follow given instructions, right? We should follow
Yes,
instructions.
sir.
Right. So that's the most important lab rule. Secondly, no eating or drinking in the lab. Why shouldn't we eat or drink in the lab?
Sir,
Because it
because
can
it's
spill
like
stuff and
drink.
damage the
So,
equipment.
sir.
All right, one at a time. Who is going first?
Me, sir.
Me, sir. Sir, because I have chemical and so forth, sir.
All right, that's the one reason, but not the most important
So
reason.
you can eat and like something go spill.
That is true. That is true. What else?
Sir. Sir, like when you dey drink, sir, and the
Mm.
drink spill on the ground, sir,
Mm.
and then you go sleep, sir. You can
Alright.
turn over chemicals by yourself, sir, and burn you up.
Right, that is also true. Anyone else? All right.
So
So
it can damage electrical equipment when you're drinking in class.
right, whenever we're drinking, we can damage electrical equipment. Right, if there's any spillage. Or and one other thing, we forgot about the rats and the roaches, right? We don't want any rats and roach infestations. So it is best that we leave out when it comes down to eating and drinking, we leave that out of our agenda. All right, what's the next one? The next one is no experiment should be conducted without safety gear. And why is that so? Why shouldn't we conduct experiments without safety gear? For example, a lab coat, right?
Sorry.
If there are any harmful chemicals, right?
It
Sir,
can damage yourself.
sir, like acid and so forth, sir.
Right. Or let's just say we want to protect our clothes, right? We don't want our clothes, our uniform to be damaged, right? So we wear lab coats to protect our uniform, right? All right. The next one is no form of horseplay will be tolerated, right? Why? Why no horseplay? Why can't I play in lab?
Sir, because you can easily bounce over things.
Easily bounce over things and damage equipment, right? And the last one is ensure that all gas outlets are off when not in use. Why? Why we turn off all the gas outlets?
Sir,
Sir,
because it
because it
can
can catch a
cause fire.
place of fire.
Right? The place can catch a fire, and what else?
And most and one next reason is, sir, because most lab chemical are flammable.
Right? Are flammable. Right? That's a good point. Travis, you were saying something?
Sir, I'm going to say could catch a fire.
Right. So the place can catch a fire if we don't turn off the gas outlets. Remember this guy over here, right? This is the Bunsen burner. We produce heat by putting in the gas, and then we get the fire out here. When we're finished with this equipment, we want to turn this off, right? Completely turn this off to prevent any fire. All right. Okay. So I think we can move on. Are there any questions before we go further?
No, sir.
All
Oh,
right. So
sir.
we're going good so far. We are on time, right? All right. So the last thing for this particular class we want to cover is the lab format, right? Lab format. Now the lab format, this is stipulated by the CTEC examination, right? CTEC is the Caribbean Examination Council, CXC, right? And it consists of the date, right? We know what this is, our topic, and our aim, right? Our aim, this is essentially what we want to achieve. So what we want to achieve for our experiment. So this is what we want to achieve for our experiment, right? Then we have our materials and apparatus. So this is what we're going to use to complete our aim, right? To complete our aim, right? And our method would be steps, the steps that we will take to complete our aim, right? All of these notes we will post it on Google Classroom, right? So you don't have to really write them down, okay?
Yes, sir.
Yeah, they will post it on Google Classroom. The results is from our method, right? These are the things that we got from our method, and not all labs have calculations. Some labs don't have calculations. But our precautions now, these are things that we put in place. So these are measures that we put in place or that are implemented for safety, and to ensure that our aim is complete. Right? Our aim, right? The computer is moving a little slow. That's why you're seeing it looking like this. Right? But it's to ensure that our aim is complete. So it's for safety, and it is to ensure that our aim is complete. So these the source of error now. Let's just say we have a lab to um what would that lab be? Or lab, for example, to um, to prove or to investigate an object falling. So we have an object here. We have an object here at this height, and the ground is here, right? So we want to prove that an object will go down instead of up, right? We know that the object will go up, go down, right? We want to prove that an object will go down. So that is our aim. Now, what would our apparatus be? Our materials. What are some examples of our materials here? Right? What are
Things
some
that you
examples?
going to be using in the lab.
Yeah. So we'd use what exactly here? What is this right here? Right? We want to prove that a ball will fall. Whenever we hold a ball in the air and we let it go, it will fall. So that is our aim. What are some materials that we can use or equipment that we can use to prove that? We'd
There
use
a
the ball,
ball.
right? Yeah, we'd use the ball. We'd use the ball, and we could also use a
Ball
ruler.
or apples, sir.
Yeah, we could also use an apple, right, to prove, and we would also need a ruler to see the distance, right? So our steps now would be to hold the ball in the air, and of course we could also use a stopwatch to see how long it will take to fall. So we see some more materials that we just spoke about coming out. So we need a ball, we need a stopwatch, and we need a ruler, right? And we hold the stopwatch in the air, we hold the ball in the air, and we start the stopwatch, and we look for the time it would take for the ball to fall, right? And when it reaches the ground, we stop our stopwatch. So that would be our method, right? So you have different sources of error coming out here. For the sources of error, one source of error could be that we don't stop as we let go the ball, we don't start the stopwatch at the same time, right? That could be a source of error, or reaction time could be a source of error. So, agreed, right?
Yes, sir.
Yeah, we could, because it wouldn't be accurate. So our source of error are things that are mistakes that we could make, essentially mistakes that that could cause the experiment to not be as accurate as it possibly can, right? So these are some mistakes that we could make in the experiment to stop it from being fully 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 um fully accurate, right? And limitations are some things that we cannot control, we're not able to control. So these are uncontrollable, right? Uncontrollable. I'm sorry, the computer is moving a lot slower than it usually does. That's why you're seeing it moving like this, right? So these are uncontrollable. So one uncontrollable thing could be what? What can we not control? In this case, we want to see how long it would take for the ball to fall, right? Um, one uncontrollable thing could be the breeze, right? The breeze could have a slight effect on it, right? Effect on the ball. So we can't really control the air, right? So these are just some things that we can't control. So let's just go back through them again one more time. We have this the lab format for CSEC. This is what you're required to know. As I said, you don't need to write these down. These will be posted on Google Classroom with some explanations of the important ones, right? So the date, of course, we would need a topic. Right? We need a topic, and let's just say we have an aim. So the aim is what we want to achieve for that experiment, right? Our materials, however, is what we're going to use to complete our aim. So as I said, our aim is to prove that when we let go a ball in the air, it would go
Sir,
down instead of up. I hear a question?
scientists use this format.
Yeah. Yeah, even up to the university level, right? We use the same format going up to university level. We need an aim. We need to show what we're going to use, right? We're going to need to show how we actually went about. So you're learning how scientists actually go about writing experiments and so forth, right? All right. So as you said, our aim is what we want to achieve. Our materials are what we're going to use to complete our aim, right? So in this case, we want to prove if a ball will fall, we'll use a ball. Of course, that would be one of the things that we want to use to prove that. And then we want the steps. The steps would be the method that we're going to use to complete it, right? So we want to prove, we want to take the time that it would take, we want to get the time that it would take for the ball to fall to the ground. Of course, we need a stopwatch to measure the time. So we have a ball here, and we start our stopwatch at the same time. We start it and we let it go, right? After we let it go, when it reaches the ground, that's the time we'll stop our stopwatch, right? That's the time we'll stop our stopwatch, all right? So that is our method. That's the steps that we take to complete. And our results now, results are what are the information that we get from the actual experiment. So the information of the time it takes to complete the experiment. Calculations, not all labs will have calculations, right? Precautions. So these are measures that are put in place or implemented for safety and to ensure that the aim is complete. Remember, I will post these on Google Classroom. So you don't need to write them down, and you don't need to worry about my handwriting. Right? I'll type over them before I post them. And sources of error. So sources of error that are mistakes that we can make as humans, right? Some possible mistakes. So in this case, we have a ball and we have our stopwatch. We might not start the stopwatch as soon as we let go of the ball. So we have our ball and we let it go, right? There could be a small difference in the time we take to start our stopwatch and the time we take to let go of the ball, right? That could be a small difference. And our limitation, these are some uncontrollable things, such as the wind. The wind could slightly affect our ball, right? And the time it takes to complete it, right? And the final thing is our conclusion. Our conclusion is based on our aim. So if we prove, our aim was to prove that the ball will fall, go down, our conclusion will be that yes, the ball will fall if we release it, right? Any questions here? Are we good? Want me to repeat any step?
Yes, sir.
We're good? All right.
Yes, sir.
All right, wonderful. Anyone else has any questions? Any concern? Want me to go over anything?
No, sir.
All right, so this was good. This is a good exercise. We will stop here, and then of course we go for lunch, and then we'll come back. All right, and then we'll go into calculating the area. It's a lot we covering today, but we have to do it right. In the meantime, what's next? Yeah, we'll go to area and volume now next class. For next class, we go to area and volume. This is very easy, right? Remember you do area and volume in maths, right? So
Yes, sir.
if you how is the online class going so far? How is online going? How about
Good,
it?
but sir,
Yeah, go ahead.
sir, you're going to, sir, the work that is due Friday, sir, it's going to be delayed 2 days for me, yeah?
All right, no problem.
Okay. So
All
you
right,
get it Monday.
all right, all right. So we'll end, and you can go for lunch. Make it an early lunch. If there are no more questions. All right. Who is playing games in my class?
Sir,
Yeah, here another question. Question? All right. Um, we will go for lunch and come back. All right. Remember, the class resumes at 12:30. All right. So I'll end this meeting now.